Okay, question 8, 7 and 8 together now. V equals F lambda, and of course, sorry, forget about that, it's rubbish, I'm not doing that there. V equals S over T, velocity is distance divided by time, and this is a reflected thing, so it's gone 18 and back, yeah, so it's twice that divided by the time, 0.11, that gives us 330 meters per second, which is the speed of sound. For B, the source now emits a continuous tone of a certain frequency, and it's the observer walking towards it hears regular rise and fall. So we want to say basically any three of these points, that there's a reflected wave and incident wave, that they interfere, well actually no, these 3 points here, and that when they destructively interfere, it's a minima. Question 8 pretty much wants you to repeat question 7 really. Explain how maximum and minimum are formed. Basically, we need to basically say there's an incident wave and a reflective wave. Constructive interference causes maxima, destructive interference causes minima. Now, question B, quite cool, interesting. We've got to remember that these standing waves are the superposition of a wave travelling in one direction and the reflection travelling in the other direction. So it's always good to draw your sort of fundamental wave like this, and then think, okay, draw your little sort of your reflected wave, if you will, and think, okay, this is where you're going to have maxima, this is always going to be a node, this is always going to be a node, always going to be an antinode, and so on. And we know that we've got, it says in the book, we've got, starts at a minimum and goes to its 9th minimum, going through 9 maxima. So there we go, 1, 2, 3, 4, 5, 6, 7, 8, 9 maxima, and 1, 2, 3, 4, 5, 6, 7, 8, the 9th minima. Sorted. So that distance there is 144 millimeters, and of course that whole pattern there is one wavelength. So we can see we got 1, 2, 3, 4 and a half wavelengths. 4.5 lambda is 144 millimeters. Dividing that by that, we get 32 millimeters is the wavelength of the wave, lambda. There you go. And then finally, it wants us to calculate the frequency of the microwave transmitter. Well, frequency is c over lambda. 3 times 10 to the 8 is the speed of light. 32 times 10 to the minus 3 is 32 millimeters, and that gives us 9.375 or 9.4 gigahertz. And that is the answer to that. Again, this is a 3-mark question, so basically it's really recognizing that it's 4.5 lambda really is the key thing there. 45, I don't know, do a diagram. Actually, no, tell a lie. It's 1 mark for recognizing it's 4.5 lambda, 1 mark for getting 32, 1 mark for plugging that into there. There you go. Right, enjoy.